In this video, we're going to be talking about applications of the normal distribution. We've already talked about the normal distribution itself, and so now we're going to be talking about how we actually use the normal distribution. Remember that normal distributions can come with any mean or positive standard deviation, but we want to convert those values into z-scores by what we call standardization. And so we let the x be the values from the normal distribution with a mean of mu and sigma being their standard deviation. And so we use the z equal to x minus the mean, mu, divided by sigma, their standard deviation. And so we convert everything into z-scores. This way we can compare, and we've standardized it, normalized it, and we can use the standard normal chart to look at probabilities, areas, everything. Remember that we want to round z-scores to 2 decimal places. Multiple reasons. Main reason being that the cumulative standard normal table is built as 2 decimal places. So let's look at an example of this. And we have a pediatrician obtains the heights of her 203-year-old female patients. The heights are approximately normally distributed with a mean of 38.72 inches and standard deviation of 3.17 inches. Lizzie is 35 inches. Find and interpret the z-score for Lizzie's height. So we know that the pediatrician has 200 female 3-year-olds. So this would be like our n, how many total we have. We have a mean of 38.72, so our mean is 38.72, and our standard deviation is 3.17. So our sigma is 3.17. Lizzie's height is 35 inches. So that's our x, the one we're comparing it to. We want to find Lizzie's z-score. So we're going to take z is equal to x minus mu divided by sigma. So that's going to be 38.72. Nope, I've already got it backwards. Let me look at that again. That's actually Lizzie's height, 35, minus our mean, 38.72, divided by our standard deviation of 3.17. So our z-score, remember to do your normal order of operations. Do the subtraction first, 35 minus 38.72. That's going to give you a negative 3.72 divided by 3.17. So Lizzie's z-score, after I do that division, is going to be negative 1.1735. I need to round to 2 decimal places, so that's a negative 1.17. So Lizzie has a z-score of a negative 1.17. What it means to interpret this is that she is 1.17 standard deviations below the mean height. And the reason why she's below is because she has a negative z-score. Negative z-scores are below the mean, positive z-scores are above the mean. Because recall, 0 is here, positives are here, negatives are here. And just to think about that, well, Lizzie's only 35 inches, the mean height is 38 inches, so it would make sense that she is below the mean height. So let's look at this Chips Ahoy problem. So the number of chocolate chips in an 18-ounce bag of Chips Ahoy chocolate chip cookies is approximately normally distributed, with a mean of 1,262 chips and a standard deviation of 118 chips. So I'm going to stop right there, and I'm going to kind of box those two, and I'm going to say my mean is 1262 and my sigma is 118. What is the probability that a randomly selected 18-ounce bag of Chips Ahoy contains fewer than 1,000 chocolate chips? Let's just start with A, and we'll forget about B and C for a moment. So part A says fewer than 1,000. So first thing to do is to draw your normal distribution curve. So right here is our middle, our mean. That's 1262. We want to look at fewer than 1,000. So right here is about 1,000. Fewer than, is that going to be above or below? Well, fewer than is going to be like 900, 800, 700. So that's going to include to the left. We want fewer than, we want less than. So I'm going to shade over here to the left. And I want to know what this area over here is. So I need to find out what the z-score for this right here is. So I'm going to find out what the z-score is. So that's 1,000 minus 1262 divided by the standard deviation, which is 118. Again, I'm going to do that subtraction and get a negative 262 divided by 118. And I'm going to scroll down just a little bit to give me some more room. And when I do that division and round properly, that gives me a negative 2.22 instead of 20. It gives me a 2.22. So I have a z-score of a negative 2.22. And I'm wanting to the left. Well, that's actually really good because the table, remember, gives us to the left. So let's look at the table. And we had a negative 2.22. So a negative 2.2 and another 2 right here gives me a 0.0132. So this area right here, let me get my mouse to quit doing that, this is 0.0132. So the probability that a randomly selected (18-ounce) bag of Chips Ahoy contains fewer than 1,000 chocolate chips is 0.0132. Okay? Now let's look at that part B. What is the probability that a randomly selected 18-ounce bag of Chips Ahoy contains between 1,000 and 1,400 chocolate chips? So in this case, since I want a between, I'm going to have to look at finding both z-scores. Because here's our 1262. Here's my 1,000. Here's my 1,400. Recall that our table only gives us to the left, so this one, once I get the z-score, is going to give me over here. Well, where I get the z-score of the 1,400, it's going to give me all of this plus all of this. So it's going to give me everything over here. This one is going to give me this. I only want in here. So since I want between, I've got to do the subtraction. First things first, though, I got to find the z-score for both of them. So z is equal to 1000 minus 1262 divided by 118. And that gives me a negative 2.20, which we had already found that. Actually, that should give me a negative 2.22, not 20, 22. 22. And then a z for the 1400 minus 1262 divided by 118. This is going to give me a positive since it's on the right-hand side. And that's going to give me a positive 1.17. Well, I've already looked up this one because that was on the previous problem. That was a 0.0132. So I need to look up the one for 1.17. So I need a 1.17. So it's 0.8790. So that's going to give me a 0.8790. And so I'm going to take 0.8790 minus my 0.0132, and that will give me 0.8658, which is this area in here. I took the difference, which gave me the leftover portion. Okay, so the probability that a randomly selected 18-ounce bag of Chips Ahoy contains between 1,000 and 1,400 chocolate chips is 0.8658. Now let's look at that last problem, part C. What proportion of 18-ounce bags of Chips Ahoy contains more than 1,200 chocolate chips? So here we want more than 1,200. So we're looking at, here's our 1262. And we'll say about right here is 1,200. And we want more than, so more than is to the right. Now recall, we can do the right one of two ways. We can either take 1 minus, or we can't, because remember your table is going to give you over here, and so we're going to take 1 minus that value, or you can look up the opposite sign. Either way. So I'm going to find the z-score of 1,200 minus 1262 divided by 118, and that's going to give me a negative 62 divided by 118, and rounding properly, that's going to give me a negative 0.53. So now then I go over and look up a negative 0.53, so a negative 0.5, and then a 3, which will be right here, so 0.2981. So that means that this is 0.2981. So I need to subtract that. And 1 minus that is going to give me 0.7019. Remember, anytime you want more than, greater than, to the right of, you always have to do 1 minus. Okay, the scores earned on the mathematics portion of the SAT, a college entrance exam, are approximately normally distributed with a mean of 516. So here's my mu. and a standard deviation of 1/16. Those that score in the top 5% are invited to Ivy League schools. Those scoring in the bottom 5% are encouraged to retake the test. What minimum score does a student need to score to be invited to an Ivy League school? And what minimum score does a student need to score to keep from needing to retake the test? So basically what it's asking is, we have this test, the SAT, and we have a mean of 516 with a standard deviation of 116. And those in the top 5% over here, so 5% here, are invited to the Ivy League school. What score do you need to make to get into the Ivy League school? Okay, so these top 5%. The bottom 5% over here need to retake this test. What score do you need to make to keep out of that? So we want to look at these. So the first thing we need to do is we need to find our z-scores for these. Well, this one is not too bad, because remember that 5% is the same thing as 0.0500, and I can look that up. Well, if this is 5%, that means that this right here is 95%. So what I can do is I can look up 0.9500 to find out this z-score. So let's go and look up 0.005 or 0.05. Remember, anytime you're given the percentage, you're going to be looking in the center of the chart, and I'm looking for 0.05 here. So here's 0.01, 0.02, 0.03. Okay, here's where it changes from 0.4 to 0.5. So 0.4 to 0.5. Okay, I cannot find exactly 0.5. Previously, I told you to take the one that it's closest to. Well, we have a problem. They're equal distance. They're the exact same distance apart from the 0.5. So what we're going to do is actually, this z-score is a negative 1.64. So negative 1.64. This one is a negative 1.65. A negative 1.65. We're going to take their average. If they are exactly equal distance apart, we're going to take their average. So we're going to add negative 1.64 to a negative 1.65 and divide by 2. And we get a z-score of a negative 1.645. This is for the bottom part. So my z-score down here that I'm going to be using is a negative 1.645. I'm going to look for the 0.95 now. And I'm actually going to end up finding the exact same thing happening. And guess what? It's 1.64 and a 1.65. So I'm going to get a positive 1.645. Anytime, again, if they're exactly the same distance apart, take their average. And so I'm going to come back here, and this is going to be a positive 1.645, which actually should not surprise us. This is 5%, this is 5%. The chart is symmetric, so these values should be the same, just opposite signs. Now, remember that I have my z value, and usually I use this formula and I try to find my z value. Well, with a little bit of algebraic manipulation, anytime we're given our percentage, given our z-score, and we want to find our cutoff value, our x value, we can actually use this formula right here. X equals mu plus z times standard deviation. So it's our mean plus our z times our standard deviation. And so I'm going to do this twice because what I want to do is I want to look at the Ivy League and I want to look at retaking the test. So for the Ivy League, I have the 516, which is our mean, plus a positive 1.645, because remember that's on the top, times the standard deviation, which is 116. To avoid retaking, I have 516, plus, instead of a positive, I have a negative 1.645, times 116. I'm going to solve these down. 190.82. And honestly, it's going to be the exact same number, except negative 190.82. So this is going to be 706.82, which is going to round to a 707. This one is going to come out to a 325.18, which will round to a 325. So a student needs to make a 707 to get into an Ivy League school, and a student needs to make a 325 to avoid retaking the test. Now try some of these with the applications of the normal distribution, and let me know if you still have questions.